Hi guys, welcome to conic sections, and we're going to be looking at the conic section, the parabola. And what we're going to be doing with this is we're going to use some specific key attributes, and we're going to construct the most efficient quadratic equation given these key attributes. And these key attributes are going to be new to you because these are dealing with conic sections, which is more of a geometric term. So let's look at some of that. We already know about parabolas, that the a in front of the x squared, if it's positive, we know that it opens upward. So if a is positive, we know our little parabola is like a happy face. We know if a is negative, we know it opens downward like a sad face. We also know that the highest or lowest point, the min or max, is the vertex, and we know our parabola, it's U-shaped, is going to be symmetric around the axis of symmetry. But what if it's not necessarily a function? A geometric or geometry-related definition of a parabola is the set of all the points that are equally distant from a fixed point, the focus. So there's the focus. He's inside but not touching the parabola. And we have a line down here. This is our line. He's called the directrix. So every point that is the same distance from them is going to be on the parabola. So from the focus to the parabola, say that is 5. It's also the same distance that it is from the line. That's what we're saying. That special line is called a directrix. The focus is that special point. And every point that's the same distance away, so let's say we have a point over here, and say that's 10 away, the distance to that directrix or that line is the same amount. It makes a parabola. We also know our axis of symmetry goes right down the center because we have a vertex right here, and our axis of symmetry chops our parabola down the center. If our parabola is like an upside down U or a right side up U, one of these, it's a vertical axis. They're talking about the axis of symmetry. And these are the equations that go for it. We have the standard, vertex, and conic form. There's also a root form, but we don't really use it much here. We have some key attributes, the vertex, the focus, the line of symmetry, and the directrix, and formulas for them. But we also have parabolas that go the other way, like C-shaped and backwards C-shaped. That means they're a horizontal axis of symmetry. And again, they have a standard form, a vertex, and a conic form. And they also have key attributes, the vertex, focus, directrix, and line of symmetry. So first of all, you got to know which way your parabola is facing, whether he's vertical, up and down, or horizontal, like a C shape. And so you can get the right set of equations. So our first example, this one is a quadratic function, actually equation, and he is drawn, here's the parabola. See a little U there. It looks kind of like a C. And the directrix, that's the dashed line. And it says we want the actual equation that describes that parabola. Well, we're going to go about this the easiest way since we have a picture. I'm not going to totally ignore the directrix. The directrix, by the way, we do know it. The directrix, that's the dashed line. He's at x equals -4. And we see the vertex also on our parabola. Here's the vertex right there. He looks like he's at -2, 2. And those are some things that we actually know about him. We also know he's C-shaped, so he's a horizontal set of formulas since he's C-shaped. But, like I said, since we have a picture, a graph, I'm going to go even easier. I'm going to use the fact that we can find 3 points on this picture and use our matrices. Much faster method. So I'm going to use something that we did the week before, which is about 3 points. So I'm going to find 3 points on the graph. Obviously, there's one at -2, 2, the vertex. But if I look on here, I have a y-intercept at 0, -2, and another y-intercept at 0, 6. I found 3 points. And what do I know about my 3 points? Well, I know about that RREF thing, but I'm going to have to change it just a little bit for you guys. So I'm going to write up here my changes. Now remember last time I told you we put x squared, then x, then 1s, and then y's. Well, I'm going to be kind of a little bit different about it this time. Since he's C-shaped, I'm going to put y squareds in the first column, y's, then 1s, and then x's from the points. So I'm swapping it. It's kind of like inverse. I'm inverting it. I still want to find A, B, and C. But I'm going to do it a little different with the RREF this time. So what am I going to put in the calculator? RREF of, I'm going to go for each point. Our points are x, y. So y squared, 2 squared is 4. Then comes y, then the number 1, and then x. Then I'm going to go to the next one. X comma y. Y squared, -2 times -2 is +4. -2 for y, then 1, then x. And my last one, xy. Y squared is 36. Y is 6, 1, and then x. And I'm going to put that in the calculator. What comes out of my calculator should be when I put him in, 0.125, -0.5, and -1.5. And we look to see, is he in reduced row echelon form, which he is. And so I'm going to write my equation. Now, I told you last time we always did f of x equals or y equals. But since this is C-shaped, instead of writing y equals, I'm going to put x equals a, which is 0.125. But instead of x squared, I'm putting y squared. Now b, so minus 0.5. But instead of x, I put y, minus c, which is 1.5. That's my equation that describes this. X equals basically 1/8 y squared minus 1/2 of y minus 3/2. And again, I switched the x and y because he's a C shape instead of a U shape. But it's the same steps that you have used before. Now this one is because I had a picture and I could find 3 points. It's going to be much harder when you don't have a picture and 3 points. That's where we're headed next. So here all I have is a vertex and a focus, and I know my parabola is looking downwards, and I want the equation. I could try to draw it, but I only have 1 point on the parabola. That is the vertex. So I'm going to have to do a little bit of work. Since I know that he opens downward, it's the first clue they gave me. It means he's going to be an upside down U. I know that this is going to be the vertical formulas. I also know our vertex and our focus. So I'm going to start with my vertical formulas. So I'm going to go over here. On the vertical formulas, the vertex is HK. So if my vertex is at 3, -2, I will know that H is 3 and K is -2. Now the other thing they give me is focus. If I look at the vertical formula, so I go to the slide for the vertical, and I look at focus, that is H, comma, K plus P. So if I know that my focus is at 3, -2, and 1/16, I know H is 3, and I know K plus P is -2 and 1/16. But from above, I know what K is. He's -2. So -2 plus P equals -2 and 1/16. Add 2 to both sides, I will get what P is. So P is 1/16. So I know what H, K, and P are. I need these. Why do I need these? Because I know, since I'm dealing with a conic, I've got that really weird word, focus. Anytime I have the word focus or directrix, that means I'm going to deal with a conic section for my parabola. So I'm going to use the conic equation, again, still on the vertical page. And that equation's form is x minus h squared equals 4p y minus k. Just copied that right off that slide. And what I'm going to do is I'm going to fill in what I know. X minus h I know to be 3 equals 4 times p I know to be 1/16. Y minus k I know to be -2. And then I simplify this as much as I can. So I have x minus 3 squared equals 4 times 1/16 is 1/4. Y minus a negative is y plus 2. This is my conic form, but my equation answer has to be in standard form. So what we need to do is we need to multiply all that out and solve it for y. Yep, it's a lot of work. Well, first thing I'm going to do is I'm going to try to make this thing multiplied out. So x minus 3 squared means 2x minus 3's. And then 1/4 times y plus 2, I'm actually going to multiply that. 1/4 times y is 1/4 y. 1/4 times 2 is 1/2. I distributed. And then I'm going to multiply by FOILing. X times x is x squared. X times -3 is -3x. Another -3x. And -3 times -3 is +9. And I don't like these fractions because I want y equals in the end anyway. So I'm going to clear the fractions by multiplying by 4 everything. So 4 times x squared is 4x squared. These make -6x times 4 is -24x. 4 times 9 is 36. 4 times 1/4 is 1y. And 4 times 1/2 is plus 2. And then all I'm going to do is subtract 2 on both sides. And finally at my answer. Y equals 4x squareds minus 24x's, and 36 minus 2 is 34. There's my equation in standard form. Now, I don't know about you, but that seems like a lot of work, and it is. How do I know I have to do all this work? If I do not have a picture, I'm probably going to have to look for 3 points in the problem. There were not 3 points. There was 1 point, the vertex. The focus is not even on the problem. Remember, he's in between the U inside of him. He's not on the U. He'd be like inside. So he doesn't count as a point. But if I have the weird words focus or directrix, that means I'm going to use those formulas on the slides. So I have to figure out if it's vertical, that means it goes up and down, or horizontal, those are C-shaped. It's important to pick which one first so you get the right formulas. From that, I wrote in black the formula for vertex, focus, and conic form. Since I knew what the vertex and focus were, they were given to me. Those are the key attributes. I found out what H, K, and P are. That is important. I need to know what H, K, and P are before I can start. Then I plugged them into the conic form, and then I multiplied all that out to go into standard form. A lot of work, but that is exactly